Hello everyone. This video walks through completing Packet Tracer Assignment 2.3.1.5, Configuring Layer 3 Switching and Inter-VLAN Routing. This Packet Tracer assignment is a part of the Cisco R&S Scaling Networks version 6 curriculum. Now in this lab, if you look over to the left, we have our topology. We have our traditional setup that we've been configuring as far as having trunk links across each switch to switch. We've got our PCs that are probably going to be in different VLANs and access mode. Our trunk links need to carry all the VLANs. Our access links just to the end devices only need to carry one VLAN. But we usually have a router here for router on a stick or inter-VLAN communication. So we have a sub interface for every VLAN so they can carry it across one port instead of having to have a separate port for every VLAN involving a router. Well, we have something special in this lab, a Cisco Catalyst 3560, which is a layer 3 switch, or what we call a layer 3, because remember, switching takes place at layer 2. It's usually dealing with just the MAC address and the physical addressing of your end devices and getting it to the right place or the next place, where the layer 3 is worried about IP addressing, which routers tend to worry about, and that's why we say switching happens at layer 2, routing happens at layer 3. Well, this switch is actually capable of doing both. It's multi-layer, so it can operate at layer 2 and layer 3. Generally, they are a little more expensive, so you kind of have to weigh the options there. So this layer 3 switch is going to be capable of routing from one VLAN to another, just like we would have been able to do involving a router. Okay, so we're going to configure the layer 3 switch first. These are some commands we haven't really practiced yet. So we're going to type enable, configuration mode, interface G02, and we look at it. G02 is the port that we've got connected to our cloud over here. And usually we just have the cloud infrastructure as like outside networks. So interface G02, we're going to do no switch port. The reason we type no switch port is so that we can actually assign a port an IP address. Usually we don't assign individual ports IP addresses on switches. Usually we only are concerned with maybe like a VLAN interface, but not a specific like for instance FA018, right? We don't usually assign that a IP address. That's usually on a router. So we're able to do that here by typing no switch port and then IP add 209.165.200.225 255.255.255.252 is the subnet mask. Now remember, we put a subnet mask of like a /30, which is a .252, because usually that's like router to router. It's only got 2 usable hosts, so that's why we usually set that instead of taking up a whole address and block. So let's try to ping our cloud. So ping 209.165.200.226, which is the other end there. So it's pinging out to the cloud there, and we got a success rate of 80. So if we retry it, we'll probably get a success rate of 100. So we're good there. Now we've configured it. The MLS switch can now talk to the cloud infrastructure. All right, so let's go back to configuration mode. In step 2 here, it wants us to configure interface VLAN 10. That is what we're used to doing. An IP address on the actual VLAN interface. 192.168.10.254, 255.255.255.0. Okay. Oh, let's also make sure that it's type no shut. Make sure it's on. Okay, it is. All right. Then if we do a show IP, or sorry, we need to enable IP routing first. So we need to do IP And again, the IP routing, and the only reason we're doing this is so that it can actually operate at that layer 3. And every switch can't do this. Our normal 2960s cannot do this. This is a 3500 series. So if we do a show IP route, which is a command we're used to only being able to do on a router, we actually see our directly connected device here, right? So that is a good sign. And it'll learn about more as we kind of go along. All right, now let's add our VLANs. So we got VLAN 10, name staff, exit, VLAN 20, name student, exit, VLAN 30, name faculty, all right. Now let's finish out the other interface VLANs. The interface VLANs basically take place of what we used to use, these sub interfaces for the router. Remember, we used to have like G0/1.10 and so on. This is taking place of that. So we did interface VLAN 10 a while ago. So we're going to use our addressing table and do the other one. So interface VLAN 20. And we're going to do IP add 192.168.20.254, 255.255.255.0. And again, that was the command. It just kind of went in the middle of it, but that's okay. Interface VLAN 30, IP add 192.168.30.254. Sorry, that's another video popping up there getting finished. 255.255.255.0. Interface VLAN 99. IP add 192.168.99.254. 255.255.255.0 there. All right, so we've got everything configured there. Now it looks like got 87. Let's just double check, make sure we got everything right. Do show run. Okay, so you see how it shows up here, a little bit different than what it does on the traditional inter-VLAN routing that we're used to involving a router, but again, you can kind of see this takes place of the sub interfaces for each VLAN. So operates the same way. Traffic will flow from PC0 to switch 2 to switch 1 up to MLS and then back down to whichever VLAN PC that it was associated with. Let's do a show VLAN brief here. Make sure everything's in the correct ports. Ah, I see. I put a lowercase f for staff. Let's change that. VLAN 10 name staff with the uppercase. There we go. So now we've got 100 out of 100 on our lab. So you can kind of see the differences if you've configured the traditional inter-VLAN router on a stick configuration versus doing it on the actual layer 3 switch. So similar, a little bit different of a command, but still the same functionality. Can carry multiple VLANs. That's the goal with fewer physical ports. Remember, physical ports cost money. So the more we can travel across less physical ports, the better. So this concludes Packet Tracer Assignment 2.3.1.5.